Hello, it's Scott Manley here. After a bunch of chemistry in my rocket fuel video, I thought it would be time to actually play Spacechem, which is one of my favourite puzzle games. Now, I'm obviously going through the tutorials here. This is a story wrapped around a kind of puzzle programming game that is themed around chemistry. So you actually have a bunch of role-playing storylines. It tells you what's going on about the shuttle travelling to Centimeter to billions of kilometres away, etc, etc. All of that's kind of mostly irrelevant and filler, but it's a good thing to read. The music's pretty neat, I like it. Now the idea is you are basically writing programs, more or less. So while this does teach you chemistry, it's really more about teaching you programming, really. And I'm just following the instructions exactly, right? I'm holding the relevant key to drop the programming thing. And so what happens is my little robot's going to start here. It'll say in from the alpha channel, and this is my alpha input here. And if you look on the left here, you can see that oxygen will come in. Then it'll grab it, travel around this way, rotate it, which is kind of unnecessary, but apparently it's showing you how to do that anyway as part of the tutorial. And travel around, it'll drop it again, and then it'll output it. So if I press play, we can watch that happen. Look at that! Output. And so now this value goes up on the right hand side, and I'm, completing the task. So if I go very fast, task completed. It's not the fastest, I can do it much faster, but it will leave up those training windows. And yeah, continue the story. So we go forward to slightly different. And it explains about atoms and molecules and how you can have different molecules that do the same thing, and these molecules are all different. It's all to do with the bonding. It tells you the identity of a molecule is determined by the type of its atoms and their bonds. Rotation and the angle of the bonds do not change the molecule's identity. Although not strictly true, given, well, there are differences that can happen depending upon angles. Okay, so it actually tells us that it's talking us through it here, so we're gonna go through this again because otherwise I'm gonna have all the stuff going on. So now it says I gotta figure the rest out for myself. Well, obviously I'm gonna do this, complete the loop. And since I'm grabbing here, I'm gonna drop here. Oh, I can just drag these if I like. And that should work. Let's see. Look at that. See, it's going out in the different channel. Problem solved. Excellent. Also note, this game's a few years old, but it actually includes YouTube support. It has a powered by YouTube logo. I haven't seen that in many, many games. Crossover. So let's do crossover. Now, crossover makes things more complicated. You start out with gold coming in the alpha channel and platinum in the beta, but you have to output the platinum to the psi, and the gold has to go out through the omega channel. So I'm just going to do this relatively quickly. Now, one thing is you can't actually have these things collide. That's an important problem here. So I'm just going to do the shortest route for this one. And the blue, so this one needs to grab. Oh no, it needs to do a grab drop here. And it needs to input here, grab here, and output here. Similarly, we're going to switch to this channel. And we want to have a loop of roughly the same size, right? So that they take the same amount of time. We're not going to use synchronization instructions here. So that's going to be the same loop, I believe. So this one we're going to drop here and do output. Output. Aha. Output psi. And this one is going to do output omega. So you can right click on the instructions to change them. And input here. And where's the grab drop? Remember. Oh no, grab drop should be here. Okay. So this should all work in theory, assuming they don't collide. And we'll see what happens in super slow-mo. Look at that. Just, oh, that's gonna fail. Oh no, it's perfectly gonna work. There, and so I can just time accelerate this through. Isn't that nice? No synchronization or anything needed. You see, this actually teaches you more about programming than it does about chemistry. What we have is two threads coordinating their activity together. So let's continue, and we go on to an introduction to bonding. Well, of course, it's chemistry. Chemistry is all, it's not about just about elements, it's about how those elements bond together. And you can see you have this new widget, which when you have the bonding instruction, will connect them together. And so actually it's going to tell me exactly what we need to do. So it says move this up here. I need input alpha down. Oh, I need a grab. And so actually make that a grab, I right click on it and make that move that way. Now it says switch to the blue, which I do by hitting tab. And to do input beta, I click R, up. Grab is E, right click, grab. And we'll go this way. Now we need the bonding sites moved here, right? Because you can't make a bond unless you have one of these chemical things. Now, one of the things that's going to happen here is this one is going to take a lot longer to get around here, but we have to make sure they arrive at the same time. So we have something called the sync instructions. These synchronize the operations, and of course that is supposed to be the red layer. Similarly, we're going to drop a sync instruction here. Now this one's going to drop it in this location, and we'll make that a drop instruction. And this one gets the bond instruction. Good evening, Mr. Bond. Yes. And this one, of course, completes its loop. It's going to make this one drop the stuff here, so I guess I'm going to do that. And then drop here. It insists I do it this way, but I guess that's what's going to happen. I can solve these levels without the instructions, but I don't know if there's a way to turn them off. And look, there, you see, we're now making gold fluoride. Scary stuff, I'm sure. Yes, enough of that. I don't think you can make particularly good rocket fuel from gold fluoride. A brief history of Spacechem. So at this point it says, new story. In the training facility on Cernemere 42 was a campus of rectangular metal buildings connected by corrugated tunnels, blah 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 blah. Worth reading, but I'm not going to read it on this. So you can also have multiple bonds. You see that as you apply more bonds, you can make up to triple bonds. Or you can use bond reduction as well to go in the opposite direction. You know, bond reduction, that's something the bad guys out of Bond movies are obviously trying to do. Okay, so we need to grab here, right? Because this is where it drops. So the grab's going to be, oh, no, blue layer. And the grab is going to be here. Okay, and we need to put hydrogen chloride. Oh, we're going to make hydrochloric acid. Excellent. Excellent, Mr. Bond. So up around this way. And what's the best way? I guess I'll do that and that. There's a bonus for making it as short as possible, right? So if I put the bond there, we put the sync here, and we need to call and request an input. We need to drop it, except we can't drop it there, we need to drop it here, and then request an output on the omega channel. Now going over to the red, we need to put this here. There we go. So that is going to drop it in this location. We need to request input here, and we need to synchronize here. So actually, let's move this one just a little ahead. Yeah, that'll work. Okay, so now let's see if this will work, right? We'll just play it in slow-mo. Picks up the hydrogen and the chlorine, and then they bond together, drop them, and output. Excellent! First time! And it tells me I took 139 cycles. There's obviously ways to make this even faster if you like. And there's also bonuses or a challenge to do this using the least number of symbols. Removing bonds. There we go. So now what we're starting with is fluorine gas, and we need to make atomic fluorine. And this is kind of interesting because for each fluorine atom or fluorine molecule, we're going to get two out, right? So yes, that's what I'm going to do. This can go around that way. And we'll just do the E will grab, R will drop it, and in alpha, outside. Oh yeah, I need to drop it here, and then I need to put it out, set the output, and we need some synchronization here. So I'm gonna make it synchronize at this point, right? Now the blue one, so what's gonna happen is this is gonna go around and draw and do the split here. So we're gonna actually do a bond minus at this location. So that will leave an extra molecule here, which the start one will just come and pick up, right? In fact, I should move my blue start one right here so it can just like hang out and wait for the thingy to come along. There, it goes like that. Look at that, right? That's gonna run in a very short loop, right? It's gonna sync there, it's gonna wait, then it's gonna do a grab drop. So this one's gonna wait for the other dude to get it. Actually, I could just synchronize here, I think. Yeah, that'll work. That'll be faster. So once this one's gone through and done the thing, this one will get the signal to go. So now I need to drop this here. We'll drop it. I guess you know, drop it as fast as possible. Do it in the least number of cycles. And we need to tell it to do output. The blue one needs to output, but it needs to output on the psi channel. So I think this will work. Let's see how well this goes. Look, flies through, grabs it, drops it. Excellent. And they work like a perfect molecular-sized machine together. There we go. Not bad for 60 cycles. And so now we get to the next planet out, Cernimere 4. Double bonds. We're going to make double bonds here. Obviously, it's like moving one step up. We're going to start with oxygen, and we have to make 2 sets of bonds here. We're going to have 007 and 00 more important. So yeah, it's going to bond. Actually, yeah, let's move these around this side, and we'll have the blue one come around right there. That's a plan. Actually, they can start in the same place even, but that'll take a moment. So what do we want to do? We want to have the blue one do this. I'm trying to figure out which one I want to make dominant. We'll make the red one dominant. So it's going to do the bonding. So it'll bond, and then once it's through, it will go up and around, and it'll have to do the drop, and then do the output. And I'm holding keys. I'm basically holding down keys. You can just click on these things and drag them up there, but it's obviously a lot faster if you're dealing with the keys. So this one goes here, and then we need to synchronize there. So now the blue one has to drop an oxygen atom there. So it needs to do an input alpha as well, right? Ah. Actually, yeah, you know what? I can move this further back. Well, that's a cunning plan to reduce the number of cycles I need to wait. So that will go input beta, and then it needs to grab, drop, go down this way. It needs to drop it there, and from that point it can go around. Now it needs to synchronize once it's dropped, right? Yeah. Let's see how that will work. I may have forgotten something here. This one does the output. So I may have forgotten. I've got a sneaky suspicion I've forgotten something. Yeah, it's. Why is it stuck on input beta? Oh, because there's still something in there? Oh, it's input beta, that's the problem. Ah. Input alpha. Let's try now. Okay, see if this works a little better. There, so it goes around, drops it there, and we have double bonded oxygen output. And so now the synchronizing operation actually runs in reverse. So this should run nice and fast. Get us through. Yay! Not bad. And on the bottom end of those peaks, that's a good place to be. So this is Zachtronics Industries. It's a kind of... It's an indie game. I'm just wondering, it's on Steam. You can get it from, or you can get it from their website. It frequently turns up in sales, but then again, so does everything. Best left unanswered. There's been a lot of concerns about safety lately. And so yes, we get continued stuff about training. So now we have to make triple bonded nitrogen. And if you remember, I did it side by side. Well, you can't quite do that anymore because you only have a limited number of these. So one way to do it is to run them in this direction like this, right? So you'll drop the extra nitrogen there and pick up, pick up, pick up, and then drop, right? So this one has to grab drop, it has to bring input, and we need to synchronize there. And then once it gets here, it drops and it can output. I think that will work. Now the blue one is gonna have to wait. Now it's gonna have to... Yeah, it could actually start like right there, couldn't it? No, it couldn't. There, you see, by putting in this delay, I've kind of given myself a little bit of room for synchronization to get set up. So I hit tab. I'm going to do a grab drop there, and we've got to do the input, and remember it's input alpha. So this one goes around like that, and then we want to drop it here, right? Grab drop here, and then synchronize here. Okay, let's see how that works. Oh yeah, but we actually need bond operations. Yes. Mr. Bond, Mr. Bond, Mr. Bond. Let's see how that works. Grabs it, drops it. Triple bonded nitrogen. The power of science. Excellent. That's us making the most common gas in the Earth's atmosphere. 139 moves, not bad. So as you see, it is showing you very basic chemistry, but it's actually more showing you programming. This is much more about programming problems. Now in this case, we're having to output multiple things, so we're actually having to take these bonds apart in this case, right? So obviously we're going to travel along, and what's the best way to do this? We're going to pick up the oxygen and then leave the carbon behind. That's what I'm going to do. So we're going to set up input R, grab, and we just want to take off 2 bonds, right? So we'll do that here. And then QQ, and then convert these to negatives, right? So we're removing the bond. And we'll come around. Now wait a second, I've got the oxygen, so actually it needs to go down this way, in fact. Ah, right click, down! There we go. This may not be the most efficient solution, but it's what I've got now, I guess. Yeah, actually maybe I should do that. Oh, darn, I'm getting too hung up on being efficient about things. Well, let's just drop this here and set the output. Output omega. Output omega. So this one, the blue one, is going to hang out waiting for the disconnected one to appear here, right? So we need a synchronization instruction right here. And this one will be going up, so let's start it here. Yeah, okay. We'll just move it a little lower. There, yeah, let's do that. Synchronize. So it's going to wait for that, and then it's going to grab it from there. Go sideways. And once it's through here, it needs to grab drop. And yeah, down and then around. And it needs to signal an output to this and it needs to be output psi. Okay, let's see how this works. We have 2 sync instructions. Yes, let's see how this works. Bang bang. We have the carbon, oxygen out, carbon out. Oh, excellent. Beautiful. I guess there are people doing this faster than me. Okay. Now, an introduction to pipelines. So you're not dealing, once you get into it, you start to deal with multiple reactors, and you can have pipelines going between these multiple reactors. Each reactor can only have 2 pipes in and 2 pipes out. And so if you want to build more complicated things, you need to have multiple reactors all joined together with pipelines. So like, here's one here, we're going to start with benzene and we need to pipe it into this one. We have acetronite and it's have to go this way. So actually, surely I just draw a pipe, right? Oh. There, let's see how that works. Look at that. Oh, faster. Ta-da! Oh, that was really, really hard. So that's how pipelines connect things. There's something in the fish cake. Uh-oh, are we dealing with amines? Chipper without a trace of distress. If anyone wanted to ask about the strange accents, she only smiled and ignored the question. Training continued and we moved on to the more technical topics and fieldwork. Okay, well, so whatever. Yeah. So yeah, it's actually it's $10 on Steam, and there is some DLC for it. 63 Corvi. I'm not sure what the nature of that is, but I should probably find out since I'm making a video about the darn game. So yeah, to match, it gets to be important because you need to match quotas, right? You have to actually match your output values, and if you have too much of something, it can be a problem. So here we're going to have hydrogen and chlorine, and we're going to mix them together in a reactor. So, stick a reactor here, and we're going to hook our reactor up to that. Now oh yeah, we start here. There we go, and then this one we take out, and now standard reactor, excellent. How do we do this again? Do we double click? Yes! So now you see we've actually set our inputs. We have hydrogen and chlorine coming in. So we gotta, write our little bit of code to actually solve this. So once again, grab, drop, input, drop it. And it's gonna go this way and drop that there and continue on its way. That'll be its little loop. Obviously, we'll synchronize on exit here. So it grabs, drops, that's easy enough. This one, the blue one, has all the hard work to do, right? It's gonna run here. It needs to bond. And once it gets through, I can actually rotate this. Now, I think that'll work. Oh, actually, you know what? I don't need to do that. Forget that. I'll just delete that. Delete. I thought it would be more complicated than it needs to be. So I need to actually do the drop here. I need to do the grab here. And I need to do the output here. Input there. Input, input, input. And then we need a synchronization instruction right here, I believe. Let's see, I'm cautiously optimistic. Okay, something's broken. Oh, look, we're waiting for the pipes. That's the flashing there. So now we actually have to wait for the pipes. Okay, we're going fine now. Look at that. Full speed ahead, manufacturing hydrochloric acid for the needs of whatever hydrochloric acid is needed for. So we may digest our food a little more, or digest dead bodies. Sleepless in Cernamere 4. I'm wondering if there's some kind of love story going on. I've never actually read the stories, I admit, but I've got a long way through this. So we have 2 reactors here we can use. We need, obviously with 3 inputs, we need at least 2 reactors, right? Because we have 2 inputs in each. And we have to make this, I guess, what is this? Is this some sort of, oh, it's formaldehyde. It tells you up here, formaldehyde. Interestingly enough, you can click on this button and see all the different elements they have in the game. I'm not sure how many of these actually exist, but it'll be interesting if you can deal with nobelium and things that decay on very fast timescales. Ah, okay, this is actually getting complicated. So I guess, I mean, obviously we need a reactor here, right? So we'll just pipe these in. And what'll that do? That'll make the carbon-oxygen bonds, right? And then this one is going to have to take the output from that and send it through here. And this one's going to... Oh, wait a second. Oh, no, this is going to take... Ah, crikey. Okay, that was a really bad plan. I hadn't really thought about what I was doing here. Okay, so actually the carbon... okay, delete this. We need to think a little harder about this. Ah! No, come back. Oh, okay. I want a right-click delete pipe command. Okay. Spacechem. Okay, so we need to take the carbon and the oxygen and mix those first, right? That's what we'll do. And we can actually move this a little closer here. There. Carbon and oxygen, mix those together to make the carbon monoxide. Then we'll make another reactor here. And it'll take the carbon monoxide and mix it with hydrogen. There we go. Nice. So that should work. Is there a way I can do this faster? Well, never mind. So now we have to start. We need to make carbon monoxide here, okay? So that's easy enough. We're going to do the usual in alpha, grab drop, go down, go around, drop it here, and I forget, are we making it go? We're going to the outputs here, right? So this one doesn't do the grab drop actually. This one get delete. This one needs to do the bonding. Bond, up and around, and then we can drop it here, and then request output. And obviously we need to synchronize before that happens. Meanwhile, the blue one goes around, drops this here, and makes its little loop. So it's going to need to drop input beta, grab, and it'll do the synchronization afterwards. It'll drop it here. And that might just work. Let's just see how that goes. It has to wait. Oh! Okay, wrong. Oh, look. Oh, wow, you can see the whole thing going on. Yes, collisions between atoms are not allowed. Okay, grab drop there. And actually we should move the inputs forward, shouldn't we? Let's try playing this again just to see if it gets through. Grabs the carbon, drops the carbon, bonds, output, excellent. And that seems to work. Okay, I'm convinced by that. Now, let's go to this one. So we're gonna have hydrogen and oxygen, we're gonna have carbon monoxide coming in this way. And we need to... this is gonna be a problem actually, so I've gotta come back out again and look at this thing. So the carbon is gonna be on the bottom. I'm guessing it's gonna actually end up there. Maybe, you know what? Maybe I should drop this here. There we go, that'll work better. So that'll actually put things in the middle there with the carbon at the bottom. So that'll be the piece that I want to grab and do most of my operations with. Because I believe the output position matches the input position. And you can't actually see what's going on here, but so in theory the carbon should be there, and that's the one that I want to grab. So grab here, and oh yes, make it blue, make it blue, make it blue. Input, and then go up and around. So the oxygen will be in front of me. There, we could do that, right? And we need to output it from this one. So yeah, let's do that. We'll just do both bonds simultaneously. This one goes up. And make sure that we're in a good place to do it, and around. Okay. So that one's gonna drop there. And we're gonna do an output, but the output will be psi. And obviously we need to synchronize. We're gonna synchronize here, right? So the red one is gonna come around and it's gonna drop a hydrogen there and another hydrogen there. And then the bond is gonna happen on both of them simultaneously, right? Also, I need to add a rotation here. Yes, okay. So let's work on this red cycle. So red number 1 comes in. Actually. Yes, this is my cunning plan. Remove, delete. I like the music. Grab the music. Yes. In alpha. What am I doing? Oh, yes, R. Okay. Grabs it there, comes around, goes along, and then it has to drop it in this location. Right? Now it's gonna come... I'm just trying to think of the best way to do this. Comes over the top, and it needs to request another one here. Goes down, grabs it. When it gets here, it comes through, it needs to drop it here. And then we need to get it back to the start, right? So once this drops, it can synchronize here. And this may actually work. It's not going to work. Because the synchronize is going to hit this. Don't! I guess I can add an extra instruction. I guess I could just wait for the sync here. Hold on. I guess I can put the sync there. That'll be kind of slower. Okay, let's see how this works. It's waiting for hydrogen, got hydrogen, drops it there. Grabs the other bit of hydrogen, drops it there. Now this goes through. Bonds! Outputs! Excellent! Aha! I have solved this! And it took a really long time. I have been promoted to reaction engineer. And there's a new story about... I woke to the rustle of an envelope sliding under the door. I pulled on a pair of socks before setting foot on the cold floor. Someone gasped outside as the envelope retracted. I pressed the access panel and the door glided open. Angela sprang up, clutching the yellow envelope in her hand. Eyes wide, her blue sweatsuit dragged on the floor as she stood barefoot, her hair wrapped in the scarf. Good morning. Okay, where is this going? Yes, are these a bunch of chemical engineers in love or something? And now we move on to Danopath. But at this point, I believe we have done more than enough with not with Kerbal Space Program. No, we have done enough with Spacechem. It's a great game. It's worth $10. If you see it in a sale, it's absolutely worth it. There is an Android version. I believe there may be an iOS version, but I have an Android version on my tablet. For phones, it might be a little much, but I enjoyed it immensely. It can be incredibly frustrating later on, but when you finally figure it out, you feel great about yourself. And it does teach you a lot about programming. It teaches you about coordinating a lot of things. So it's a great educational bit of software, and I love it. I'm Scott Manley. Fly safe.